All right, so today we're going to learn how to find the area between two different curves. Now we've done the area under a curve before. For instance, if you look at this middle picture, if we take the area under the parabola, when we do the area under the curve, we're getting everything that's shaded all the way down to the x-axis. If we do the area underneath the curve of the parabola that's positive in front of the x squared, we're getting this area underneath the curve. To get the area in between them, we need to do the one that's on top, the top parabola, minus the bottom parabola. So in other words, when we do this with other functions, it's going to be the top curve minus the bottom curve. That's how we're going to get the area in between. So they have it set up right here. The area equals the integral of from a to b, f of x minus g of x. You just need to remember that f of x is the curve that's on top. So let's look at the first example. They want us to find the area of the region bounded by the graphs of y equals x squared plus 2. So we're going to have a parabola that starts at 2. It's going up. Y equals negative x. That's a line going through the origin with a slope of negative 1. And they want us to find the area between the curve between x equals 0 and x equals 1. So there's a picture here. We are looking for the area between this curve. So what we need to find is the top curve minus the bottom curve. That's how we're going to set this up. Now, before we can start, remember there's not always a picture. So first we have to figure out which one of these graphs would be on top, the parabola or the line. Well, let's start with 0, because 0, we want to do something in the interval between 0 and 1. So let's just try 0. If I plug 0 in here, 0 squared plus 2 is 2. So the point 0, 2 is on this graph. If I plug 0 in on the equation of a line, I'm going to get y equals 0. So when x is 0, y is 0. 0, 0. So that tells me that the higher y value is going to be parabola that has the point 0, 2 in it. So my parabola is going to be on top. So I want to do that one first. That's my f of x. So let's label that one since it's on top. This one is going to be the f of x. And this one is going to be the g of x. Get that back up there. All right, so we're going to do the integral from 0 to 1 of f of x, which is x squared plus 2, minus g of x, which is negative x. And all of that would be dx. Don't forget it's dx because we're integrating with respect to x. So now, when I distribute here my negative, it makes that a plus. Okay, so I'm going to have the integral from 0 to 1 of x squared plus x plus 2 dx. Now we're ready to integrate. So if I add 1 to the 2, I'm going to have 1 over 3 x cubed plus, if I add 1 to the 1, I'm going to have 1 over 2 x squared plus 2x. And remember, we don't have to do plus c because this is a definite integral going from 0 to 1. Now we're ready to do the top minus the bottom. Okay, so if I plug in the 1, I get 1/3 times 1, which is 1/3, plus 1/2 times 1 squared, which is 1, plus 2 times 1, which is 2. Add all those together. So you're going to have 1/3 plus 1/2 plus 2, and that equals 17/6. Now the part I didn't show, I guess I should, let me fix that real quick. I didn't show the minus 0 because I'd done it in my head, but let's show it. We know when we plug 0 in there, we're going to get 0. So we're still going to get 17/6 when we show that minus 0 in there. Remember, it's the top minus the bottom on the integral. And it's also the top curve minus the bottom curve. So the area between those two curves would be equal to 17/6.